Hey guys, I'm just going to run through the 2015 section B question 2 isometric question, axonometric projection. And this is a fairly okay question, a few little tricky bits on it. So I'm just going to run through on the solution of this. But the question, first of all, scale of 1 to 1. This one is an axonometric, so your axes are divided up 120 degrees between each axis, which means that you're just dealing with a 30 degree and vertical angle. Makes it a little bit easier for the projections. They tell you that the object itself is a square-based pyramid which has been intersected by a hexagonal prism. Okay, so this, you're told this is a regular hexagon in plan. Okay, and the regular hexagon is inscribed in a circle, and you can see from the question that from that point on the hexagon to that point is 15, 30 and 15, which is 60. Okay, which means from the center of the circle to the edge, the radius of the circle is 30. Okay, now what this also means from a question point of view is when you go draw on that hexagon, and this only works for a regular hexagon inscribed in a circle, whatever radius the circle it has, in this case 30, the length of side of the hexagon will also be 30 millimeters. Okay, so there's a couple of ways of drawing the plan of this. It'll be set up at 45 degree angle, like that. Okay, so just your standard 45 going that way and that way. And we know that the length of this line from here to here is 110. You have a couple of options. You can either go from the center point on this diagonal, which is at 45, and you can measure 15, 15, 15 and 15, and then go 45 in the opposite direction like that, which will give you your points on the circle. Again, the circle is radius 30. But just to show a little construction that does come up sometimes and is useful to know, that if the radius of the circle is 30, if I pick a point which I have there on that diameter, okay, and swing an arc across here, it will also intersect at that point. So basically the length of each of the sides of the regular hexagon, I can step it off there and step it off there, 30, 30, 30, 30, 30 and 30. Okay, that works, and that's only true for a regular hexagon inscribed in a circle, that the length of the side of the hexagon will be the same length as the radius of the circle. Okay, so you get that set up. Front elevation, again you can see that you're projecting out your lines at 30 degrees, bringing out your center point, bisecting to get, so that's 30 degrees, and again it's 30 and 30 because the edge of the triangle, that edge CB, is at 60 degrees, and remember our projection lines are always going to be projected out at 90 degrees to that. Okay, the line out here is at 60 degrees. Okay, and then I'm taking my center point, which is right there, drawing my semicircle, and from that center point there I'm setting up my angle, which will be 90 degrees in a semicircle. Okay, I can see from the question the base of the pyramid lines up with that point. The top of the pyramid, the height, and again if you note they don't give you an actual height on the question for that, you just have to be able to spot that the height of the pyramid or the height of the object coincides with the end of the circle. So that's going across that way. So again, if you have an adjustable set square for this, it makes life a little bit easier. You know, your lines are being projected in that direction. That top line is going out like that. Okay. So the one or two little things that make this thing a little bit difficult. The pyramid itself isn't a problem. You know, if you look at 1, 2, 3 and 4. Okay. If you can notice and remember that when you're looking in this direction at the plan to see that view. That's the important thing here. You're looking down on top of, where the blue arrows are, on top of the front elevation to see that view. Okay. If you can remember that, if I go indexing, I know that point 2 and 3 are in line with each other. So 2, 3, 1 and 4 are in line with each other. So 1, 4. When I start projecting them back, 2 and 3, 2 is there, 3 is there. There's those 2 points. 1 and 4 brought down that way. 1 is there, 4 is the back. There is the base of the pyramid. Top of the pyramid, let's call it point O, right there. Top of the pyramid projects back at 30. Top of the pyramid projects up. There is the top of the pyramid. There. Okay, so there's the actual pyramid. Top of the hexagonal prism isn't a problem. Again, index the points. Bring the points straight up. Remember that as you're looking from the red arrows in that direction, if you're indexing those points, this point and this point will be this one and this one. So just to keep an eye on points that you're bringing down. Again, generally with this, you'll know if it looks wrong. Okay, and the question itself, if you look back at, and it's the nice thing about this question, is if you look back, most of the questions there, so you should be able to look at your solution and kind of see whether or not it looks like this. It should look like this. Okay? So, the top shouldn't be an issue. Okay? So the few little things that cause a small bit of problem with this thing is the likes of maybe this edge, which is probably one of the easier ones. So that edge is coming from the edge of the prism intersecting the edge of the pyramid right there. In the plan, that's that point right there. Okay, easiest thing to do, the same as going from the center at 15 and 15 and 15 and 15 in the front elevation. If you have measured 15 and 15 in that direction and 15 and 15 in that direction. Okay, bring that line down. That line is coming down, measured from the center, it's coming down like that. Gives me that point right there. I can take that point and shoot it back to the plan at 30 degrees. That's coming back there. The same point in the plan is there. That point goes up as far as there. That gives me that. Okay. The next one. This line running across here. I'm just going to show you two ways of doing it. Okay. The way it's been done here on the solution is extending that line. So it basically is running along here. So it's basically been extended out along the edge of the pyramid to meet that point right there. Okay, so how are we getting that? In the plan, taking that point, running it straight out as far as there. Okay, bringing it up onto that edge. Okay, so that was my edge 1, 0. There's 1, 0. That point has come out as far as there. Let's call that point S. Okay, so the edge has been extended to point S. There's point S. S has been brought back in at 30 degrees. It's extended parallel to the base edge. So the base edge is at 30 degrees. So that line you'll notice also has to be at 30 degrees. Okay, and obviously then those 2 points when they're brought straight up gives me those 2 points there. Okay, now another way of doing this is to take a distance from the edge in as far as one of these points. So in the plan, I'm going to just extend this line. I'm just going to bring it out the opposite direction. And we just throw a bit of colour on it. So taking that edge and bringing it as far as there. Just going to extend it very lightly there as well. Okay, so if I take the distance from there as far as there, that distance, okay, which happens to be 10 millimeters. So it's 10 millimeters from the edge of the object in as far as the point where this line has been extended. Okay, up in this view, if I take and measure 10 millimeters in from the edge, okay, bring that up at the same angle as all the other vertical lines. Up as far as there, the point where that hits the edge, that's that point which has been extended out. I can take that point and extend it back across here. And that will, when I take that point and bring it across, that runs across where this line is here. Okay, and that will come down and intersect with the 15, and the 15 giving me that point and that point. Okay. So again, I've taken the distance of 10 and I marked that distance of 10 right there. From the corner in as far as there, brought it up to hit that edge, because I'm just trying to find this point, and then bring it across there. Okay, so that green line, if I was to put it in down here, or here in the front elevation. That line corresponds to that line there. Okay? So that's one way of getting that edge. Or sorry, that's the second way of getting that edge. Okay? Last point. This corner here is created because you have this surface on the side of the hexagonal prism. So that's one flat surface. But that surface crosses over, so these are intersecting surfaces. That green surface crosses this surface and this surface. And as it intersects with it, it changes direction. So that's why you get two lines created there. Okay. This point right here in the plan is that point right there. Okay. I think, again, the easiest way to do it, if you remember that you're looking in that direction, see the front elevation, is take the distance from the edge as far as that point. I have it marked in here in red. Take that distance, measure it from the edge up here. So I'll take that distance and measure it in, and it is 16 millimeters. So on my drawing here, that's 16 millimeters. Could mark with a compass as well. From the edge as far as that point. Take the 16, measure it from the corner in as far as there, and then bring it straight up. I'm sorry, when I'm saying straight up, but it's perpendicular to the base. I suppose it's the angle all the other lines are going at. So I'll bring that point straight up like that, and that gives me that point right there. Okay, so that's the point of intersection, or the point of crossover, the change of direction on that surface. That gives me that point. Take that, bring it back down here. This one has been brought straight back up. That gives me that point. Okay, if you're looking at the solution, you'll notice to find that point, they've done something different. So what they've done is they've taken this edge which we're trying to find and extended it as far as the base. So there in the solution, in the plan, that edge has been extended to the base. Bring it up as far as the base. Join it back to this corner, which we have, which is this one. And just to continue it up and extend it at the same angle. And that will also give you that point. So two ways of doing the same thing. Okay, I tend to like using the one where you're taking the distance straight in there, because you can use that for dividing up on other questions there. You can use it for dividing up circles and stuff like that. So that distance again, that red distance from there as far as there, that was 16. Okay, and that's basically it. So have a look at it, see what you think. If it makes sense, good. If it doesn't, to get me, ask questions. And thanks for watching. Hope that solved the problem. Thank you.